Assalamu alaikum. Welcome. Today we are going to look at chemistry, form 3, chapter 1, the gas laws. Gas laws include Boyle's law, Charles' law, combined gas law, and Graham's law of diffusion. These are the laws, the gas laws that we are going to learn under this chapter. Then we start with the first law. It's called Boyle's law. Boyle's law. And under Boyle's law, as a student, you should know various important points. The first important part is the state. You are told to state Boyle's law. Now, you as a student, you must know how to state the Boyle's law. Now, with this, the first part, stating the law. Next part, very important, is the how to sketch the graph. How does the graph of Boyle's law look like? And another important part is formula of the gas law, formula or the mathematical expression of the Boyle's law. Then another part which is very important is implication. When you are told, what does this Boyle's law imply? Implication of the Boyle's law. Then another one is molecular explanation of Boyle's law. Then we start, when you are told to state the law, you say, Boyle's law states that the volume of a fixed mass of a gas is inversely proportional to its pressure at a constant temperature. That's how you state. Then the graph. How do you sketch the graph? The graph of the Boyle's law is as shown below. It looks like this. When we draw or when we plot pressure against volume or the volume against pressure, it looks like this. We have the volume on this axis here, and this is the pressure in atmosphere on the vertical axis. This is how you draw. It look like this. The graph look like this when you plot volume against pressure, or when you plot 1 over the pressure against the volume. This is how the graph look like. The graph becomes straight. That is when you plot the 1 divided by the values of the pressure and the volumes. This is how the graph look like. Formula. The formula for the Boyle's law is as shown. Pressure 1 times volume 1 is equals to pressure 2 times volume 2. That is P1 V1 is equals to P2 V2, or V1 P1 is equals to V2 P2, where P represent pressure and V represent volume. What does the Boyle's law imply? Boyle's law implies that when the volume of a gas decreases, the pressure of the gas increases, and vice versa. Vice versa means when the volume increases, the pressure decreases. That is what it means. Molecular explanation of the Boyle's law. When volume of a fixed mass of a gas is decreased, the pressure of the gas increases. This is because gas molecules are confined in a small space. Hence, the gas molecules have to cover a short distance before colliding with the walls of the container, causing an increase in the rate of collisions between the gas molecules and the walls of the container. That is the implication of the molecular explanation of the Boyle's law. Then we are going to look at applications. How do we apply that knowledge of Boyle's law in questions? Applications of Boyle's law. Number 1, a question says a volume of 420 cubic centimeters of a gas has a pressure of 40 atmospheres what will be its volume if the pressure changes to 32 atmospheres? Now in this question we are given, we have this volume 1, V1, that is 420 cubic centimeters. Pressure 1 is 40 atmospheres. Pressure 1. Then pressure 2, also we have been given pressure 2, 32 atmospheres. 32 atmospheres. Then that's pressure 2. Then volume 2 we don't have. So then we apply the formula. Formula says pressure 1 times volume 1 is equals to pressure 2 times volume 2. Then P1 40 times 420 is equals to 32 times V2, which we don't have. Then divided by 32, divided by 32. 32 will cancel with 32. Then V2 is equals to, when you put the calculator, it will give you 525 cubic centimeters. Then next, a fixed mass of a gas occupied 500 cubic centimeters at a pressure of 720 millimeters of mercury at temperature of 42 degrees Celsius. Calculate the volume of the gas at 780 millimeters of mercury and 42 degrees Celsius in SI units. Then we are being given volume 1, 500 centimeter cube, pressure 1, 720 millimeters of mercury. Then volume 2 we don't have. Then we are given pressure 2, 780 millimeters of mercury. Then how do we get volume 2? We say V1 times P1 is equals to V2 times P2. Then we substitute V1 is 500, P1 is 720 is equals to P2 we have 780 times V2, which we don't have. Then to get V2, we divide both sides by 780, 780. This will cancel with this one, and then when you put the calculator 500 times 720, then you divide it by 780, you get 461.5 cubic centimeters. But the question says in SI units, and remember the SI units of volume, the SI units of volume is what? Cubic meters. Meter cube, or cubic meters. The SI unit of volume is cubic meters or meter cube. Hi, then we convert this centimeter cube into cubic meters. Then we say if 1 meter cube is equals to 1 million centimeter cube, what about 461? Then when we cross multiply, we get 461.5 over 1 million times 1 meter cube. Then you get 4.615 times 10 power negative 4 meter cube in standard form. Next question. At a constant temperature, a gas at 725 millimeters of mercury occupies a volume of 720 liters, occupies a volume of 320 liters. The gas is made to expand and occupy a volume of 500 liters. What is the new gas pressure in SI units? So we are given volume 1, 320 liters, pressure 1, 725 millimeters of mercury. Volume 2, we are given 500 liters, then pressure 2 we don't have, because we are asked what is the new gas pressure in SI unit, that is P2. We are asked to look for P2. Then we apply the formula P1 V1 is equals to P2 V2. Then we substitute with what we have. P1 is 725 times V1 320 then is equals to P2, which we don't know, times V2, which is 500. Then to get P2, divided by 500, divided by 500. 500 will cancel with 500. P2 therefore is equals to, when you put the calculator, 725 times 320 divided by 500, you get 464 millimeters of mercury. But we are told give your answer in SI units, and the SI unit, remember, SI unit of pressure is pascals. The SI unit of pressure is pascals. And we use this conversion. 760 millimeters of mercury is equals to 1.10325 times 10 power 5 pascals. What about 464? What about 464? Then we convert. We say 760 millimeters of mercury is equals to 1.01325 times 10 power 5 pascals. What about 464 millimeters of mercury? Cross multiply. You get 464 times 1.01325 times 10 power 5 divided by 760. Then when you put the calculator, you are going to get pressure 2 is equal to 6.186 times 10 power 4 pascals. And that's the answer. Next, we have a question here. The graph below shows the behavior of a fixed mass of a gas at a constant temperature. We have been given the graph, volume against pressure, and this is the curve. Now this graph is what we have seen somewhere here. It is here. It is this one here. That's the graph of Boyle's law. Then we asked, what is the relationship between the volume and the pressure of the gas 1 max? What is the relationship of this volume and the pressure in that graph? Then we say answer, volume and pressure are inversely proportional. Because this is Boyle's law. And we say that Boyle's law states that the volume of a fixed mass of a gas is inversely proportional to pressure at a constant temperature. So that means, therefore, the volume and the pressure in this graph are inversely proportional. Hi. B, 3 liters of oxygen gas at 1 atmosphere pressure were compressed to 2 atmospheres at constant temperature. Calculate the volume occupied by the oxygen gas 2 max. Then we look for, we have been given 3 liters, V1, volume 1 is 3 liters, pressure 1, 1 atmosphere, pressure 2, 2 atmospheres, and V2, volume 2 we don't have. So we say V1, P1 is equals to V2, P2. Then we substitute 3, V1 is 3, times P1, 1, is equals to V2, which we don't have, times pressure 2, 2, then we divide it by 2 here, by 2, 1, by 2, 1, so that we remain with V2 on this side is equals to what? When you divide 3 times 1, we have 3. 3 divided by 2, 1.5 liters. That is V2 in liters, 1.5 liters. But we are told that, we convert now these liters into centimeter cube. Then we say 1 liter is equals to 1000 centimeter cube. What about 1.5 liters? 1.5 times 1000 over 1. It becomes 1500 centimeter cube. And that is the volume in centimeter cube. V2 therefore is equals to 1500 centimeter cube. Thank you for watching.